Okay. Dear colleagues, dear research community, and dear guests, a warm welcome here. I'm glad so many found their way to our auditorium today, and I'm sure, and I even know, to be honest, that much more of you are out there in the video stream. I know the number of more than 500 being out there. And I'm very glad to welcome you all to our serious lectures, or serious Frontiers in Science, and our special lecture today on AI. I'm very pleased to introduce Richard Socher, one of our global top AI experts, to you as our speaker. It is also my honor to announce that since last Friday, Richard is part of our faculty. Friday, Richard was awarded with an honorary doctorate of our computer science faculty in a recognition of his achievements in the field of artificial intelligence. And as many of you know, this is an exceptional honor reserved to researchers with scientific impact on a global scale, and that definitely applies to Richard, and who share the values of our university. Richard Socher was born in Dresden, and I'm happy to see also his mother here in the auditorium. Studied computer linguistics. Sorry for that. That was only a proof. Studied computer linguistics at the university in Leipzig and further on in Saarbrücken, before he moved to Princeton and Stanford. In 2014, he received his PhD at Stanford University. With his PhD thesis, he was by far not the first working on neural networks, but he was clearly within the pioneers to work on neural networks for language processing, and thus to build the foundation of the functioning of large language models as we have them today, or in short, something you might like to call ChatGPT, even if that is not the full truth. Richard brought and collaborated on some of the most impactful papers in his field, and with his background, Richard thought outside of the box and explored to apply machine learning to the structure of language. He wrote some of the most cited papers on word vectors and improved methods for large language models. The launch of ChatGPT and the general spread of generative AI provided all of us with a great potential and immediately challenged us as academia, us as university with a lot of questions. How to utilize and how to handle AI as a co-creator of my research results and of my research papers. What does that mean for students, the way we offer teaching and the way we design exams? That had been a very pressing question for a number of my colleagues. Quite early, we at TU Dresden decided clearly against strongly regulating or even forbidding the use of ChatGPT and all LLMs alike. On the opposite, we recommend to make use of their potentials, to explore their possibilities, to jointly build the required competencies, and for sure we need a lot of them, and also to advance in using AI in a responsible but research-friendly and enabling manner. Richard likes to tell about a submission of one of his favorite papers on unifying the approaches of natural language processing. This paper submission had been rejected by reviewer number 2, I learned, but later had then been referenced by the creators of ChatGPT. That tells a perfect story for all young talents here. Enjoy and believe in what you do, and after first frustration, there might be an even better second chance. When Richard was offered a prestigious position to continue his research as a chair of Princeton University, he declined. He realized that his biggest impact would be in industry, as the groundbreaking ideas for the basic technology were already out there and ready for practical applications. So he first became lead scientist at Salesforce And recently he started his own startup, U.com, which is an AI-based search engine with a focus on personalization and privacy, something I like to hear as a CDIO of a TU Dresden. And if you did not yet try U.com, you should to see where we are today in applying AI. And we started negotiating with Richard on how we can best make U.com available for all of you at TU Dresden. Not only Richard has been very successful in both science and his business, but he also clearly brings an inspiring joy and curiosity for discovery to all his projects and talks, and you will see that in a second. His impressive career paired with his positive spirit and his down-to-earth attitude speak to a lot of young talents. During the honorary doctorate and several award on Friday, Richard opened with a statement that he thinks computer science is only as strong as the fields that feed it. I'm even quite sure that I'm looking at many people today, here and within the stream, that will provide food for thought to computer sciences and scientists around, and many computer scientists who open their doors for members of other fields. At TU Dresden, we strive for combining different fields with AI. We just celebrated the opening ceremony for our new high-performance computing clusters, providing you with top resources. And this is not the only it's not only the great hardware we have. With the Center for Interdisciplinary Digital Sciences, the KIDS, and its department, SCATS AI, as one of the national AI centers, we established a focus point of digital competencies to push the boundaries of this research. And KIDS is home to a lot of great points of contact for you to get started on your AI journey. And I think I could ask all the KIDS colleagues in the room to wave their arms to make you showing these points of contact. Wolfgang. Okay, you see some of them are being around. Please feel free to reach out to KIDS, join its workshops and research groups to see where your exploration of AI can take you. And if that didn't get you excited about AI and research yet, I hope Richard will, and I'm certainly curious to hear his perspective and to learn about his ideas on how to be at the frontiers of science and how AI will accelerate scientific discovery. You can clearly hear I'm already excited, and please welcome with me Richard.
Hello, everyone. I'm super excited to be here. I actually was born in Dresden-Friedrichstadt, and I live literally 3 minutes from here for over a decade. So I'm really excited. I want to tell you about this new idea that I call the Eureka machine, sort of on the side for fun, writing a book about it too. It'll take a while. Books are slow. But the main idea is that eventually we can get to use AI to basically do what we as researchers do, which is to create inventions and to push all of science forward. And that will sound a little bit crazy and a little bit unrealistic. And so I want to start with the journey of my academic research and now my company that also sounded a little bit crazy and unlikely to succeed. And then hopefully by the end of it, we can see sort of some of the ingredients that it took to make that happen, and then see that I think it will be possible also to do this again, and possibly also with folks hopefully in this room. So I think at a very high level, why a Eureka machine? Why do we need to do this? And at a high level, inventions change the entire human condition. Right? When humanity invents things that make us more productive, more efficient, then we get to choose new things to think about, new things to work on. Over 150 years ago, over 90% of all people worked in agriculture, just trying to make sure there's food on the table. If you had told those people, like imagine 90% of you every day have to work with your hands in the field. If you had told all those people back then, in 50 years from now, or 100 years from now, only 5% of you need to still work in agriculture, in the fields. They would have freaked out. They're like, what are we going to do? there's like no more jobs. 90% of us work in agriculture. And now, of course, if I asked how many of you would want to work in the field every day, none of you would say, oh, I miss those good old days of working in the fields. We are currently going through exactly that with AI. There are a lot of people who have fears also, because jobs will change. Most jobs that we currently do that have any feeling of feeling very repetitive, feeling not like requiring a lot of emotional intelligence, being kind of boring, most of those jobs will likely get automated. And it starts with digitized jobs. So my hypothesis is in about 5 to 10 years, 80% of the workflows of 80% of all digitized jobs, jobs that you mostly do on a computer, will be automated. Or could be automated. Of course, the future is already here. It's just not equally distributed, and will take some time for all of that to distribute in all the different countries and geos and whatnot. But at a high level, inventions are very exciting. And so here's sort of my journey, brief journey, towards the invention I'm most excited about. Oh, this thing's falling off. Which is an AI that we can actually talk to, and it will give us reasonable answers. And that all started with a much nerdier subject. And quick question here. Raise your hand if you're familiar with linear algebra and the definition of a vector. Ah, amazing. All right. Sorry to the 5 or 10 people who aren't, but that is great. That way I can just kind of go into some more nerdy details and nerd out here a little bit. So what we're trying to do here is train a single model, and we call it pre-trained because we want a foundation of that model to be shared based on a ton of different training data and different tasks. We call it also multitask learning. And so the first step to making neural networks useful for natural language processing at all is you have to be able to represent words as vectors. Words before neural nets were just like, oh, here's a binary vector. It's 1 for cat and 0 everywhere else. And it's another index of 1 for dog, and that's it. And that's not very helpful to have 1 million dimensional vector with a single 1 and everything else being 0 as a way to define all the words. So what we first had to do is to describe words as vectors, and those vectors ideally actually capture the meaning of those words. And that was one of my early papers with actually a physicist, Jeffrey Pennington. Fun side note since we have an hour. Jeffrey Pennington was a physics PhD at Stanford, and he basically had a summer off. His advisor was on a sabbatical. He felt like particle physics and so on was a little bit stuck. Probably is. And then he's like, I want to just do something. And oh boy, I'm very impressed. If you study physics, it will take you only a few months, and then you become a computer scientist and even an AI researcher. Physics is a really great background and education to do incredible work in AI. And so we had this idea to train word vectors, and now we can actually have a vector for a word like frog, and then we will know that just in a simple vector space, so inner products, cosine similarities, we get to see that a frog is similar to frogs, to toad, to latoria, and so on, and then some really specific types of frogs. And we can even start to do vector addition and subtraction and capture meaningful information. So for instance, I can take the vector of queen, subtract the vector of woman, add the vector of man, and I would get to the vector of king. And the way to train these word vectors is just by simple contextual similarities. How often does this word appear with these other words in this context? It's a very simple idea. But all of a sudden, all text on the internet can become training data to learn about single words. And that feels obvious now, but it's a very important idea to use a lot of unsupervised raw text on the internet and predict words around another word. We'll get to that. It's basically the other big idea behind ChatGPT and large language models, is to predict the next word and actually generate that next word. Here we just predicted them from one from another, and all of a sudden you can do incredible things, and you see in the vector space semantic meaning actually coming out, which is really great, because it's one of the things that I've been very excited about. Back in high school, I just came from my high school earlier. I had studied Leistungskurs, math and English, and this is where math and English meet, in vector spaces. So that's great. Everything is a vector. Words are vectors to start with. This is the most atomic unit of sorts, other than morphological analysis of words, which especially in German is quite exciting with zusammengesetzte Substantive, compound nouns. But mostly we have now words, vectors for words. But we also need a lot of training data. And another line of work I'd worked on was ImageNet, which is basically the first very large data set. And to be honest, the first two authors here were actually systems PhDs. They weren't AI PhDs. And it's another really interesting and useful insight for people's careers now as they're trying to go into AI, is systems are becoming more and more important. Just being a really good programmer is incredibly helpful and important for making AI work, especially now that we're scaling these systems on massive GPUs, massive distributed systems. It's incredibly helpful, and even creating large data sets was mostly a systems challenge back then. Now, of course, language connects everything. So the way we had actually constructed ImageNet was to go through WordNet, which was a project run in Princeton and all over the world, where you had these synsets or synonym sets, and you can basically collect images for all the different concepts that humans have come up with and have put into a hierarchy. It goes from mammal, placental mammals, carnivores, canine, dog, working dog, and husky, right? And you can have images for all of these. And once you have enough data, you can use neural networks to try to predict what kinds of things we see in the visual world. That was very controversial at the time to be able to really solve that. And there are actually some famous computer vision professors who made bets saying, I will stop working in my field if you actually solve this whole data set and you can classify with over 95% accuracy, or if one scores all these images. And they actually have stopped doing pure computer vision on just object classification. One of them is a famous professor in Berkeley, the most cited vision professors in the world. I won't name him now. And now what they're doing is combining computer vision with robotics, combining computer vision with biology, because this simple computer vision problem of what object do I see in this image is pretty much solved at this point. And yeah, there are over 14 million images in this data set. Personally, for me, I was working on a lot of natural language processing problems, and one of those problems is sentiment analysis. Just the idea of basically identifying if a sentence is positive or negative. It's very helpful, right? People want to understand in movie reviews how often was this positive or negative, hence how well will the movie do in the box office. A lot of people in financial trading want to use sentiment analysis, right? If a product comes out of a company and it's all the reviews are very positive, you can immediately start trading and buying more stock for that company. In fact, back in the day, there's a curious correlation where Anne Hathaway starred in a movie, won another Oscar, and then the stocks for the company Berkshire Hathaway kept going up. Every time Anne Hathaway stars in a movie, positive reviews, Berkshire Hathaway goes up. It's what we call a contextual disambiguation problem, or entity resolution. But back to sentiment analysis. I trained all these fancy neural networks. They understood the structure and the syntax of language, and they just trained based on raw data. Here's a positive sentence, what's the sentiment? But my algorithms weren't that much better than some of the very simple algorithms, namely called bigram models, that just take words and give them a different weight, and then they take bigrams, not good, for instance, is a bigram of 2 words, and they give them different weights. And my algorithms didn't do that much better, and we actually saw this for many years. Neural networks were sort of joked as the 3rd best method for everything. All right? And so no one cares. No one cares about the 3rd best method. And so what I realized at some point is I have to create a larger data set. And these are not crazy large numbers. They're like several tens of thousands of sentences. But we actually labeled every single grammatical phrase in like tens of thousands of sentences. And this is kind of what it looked like. We had this beautiful visualization. And you can now look at much more interesting and careful semantic structures. So this is a movie review. The movie was named Stealing Harvard. And the sentence says, stealing Harvard doesn't care about cleverness, wit, or any other kind of intelligent humor. You read it kind of just from left to right here in these syntactic diagrams. And the beauty of this kind of sentence is that every model out there would get it wrong. And it had no chance of getting it right. Because when you look at all the positive words and all the positive bigrams, pairs of words, this sentence looks very, very positive. Right? It has humor. It's got intelligent humor. It's kind. It has wit. It has cleverness. It has care. But it doesn't care about any of those things, and so it's actually negative. And when I had enough training data and enough examples, the neural network was able to capture all of that complexity, and I didn't have to write, ask a linguist. I mean, I was also a linguist. I studied a lot of linguistics, but I didn't have to go manually write out what these rules were. I could just give it a lot of training data. And there's all kinds of crazy, interesting examples, like while the film is competent, it is uninspired, lacking the real talent and wit to elevate it beyond its formula and so on. So all these, again, very positive things, but it's lacking all of that. And as a human, to write out all the rules of how can you negate something. Sure, you, as a linguist will know, well, if it's not a list of these positive words, it's probably negative. But it's very hard to list out all the ways, like saying, oh, something is lacking, something doesn't care about. Like, it's hard to write all of that out. And now imagine you have to translate. It's even harder to write out all the rules on how to translate from German to French or English or so on. So we also had to train a model that had more powerful interactions. And this is where the vectors come in. At a very high level, this was one of the first tensor networks, where each two words that were combined had a multiplicative interaction that was governed by this tensor. And what that allowed us to do is that really one word could focus its attention and change entirely the meaning of the combination of those two words, or eventually phrases. So each layer you see here, each node, was essentially a neural network that would combine the meaning of the two things that fed into it. And this idea of multiplicative governed interactions we now call attention, and this was kind of one of the first such attention mechanisms. And then we could show, okay, it is much more accurate. All these recursive neural network type models were much more accurate, and the best bigram models could only get to like 71% accuracy across everything, and we could get to 80. So almost 10% jump in accuracy. But what was even more interesting is that we could now negate positives and negate negatives. So like, this was not bad, right? Or this was not terrible, or it was not amazing. And it would actually correctly do this. And all these simple models, when you looked at a subset of the data, really had no way to actually ever understand language. They're 20% accurate versus 71% accurate. So that was a big idea for me at the time of like, these neural nets need a lot of data, and we need to just get large data sets, and anything we can get a large data set, anything we get our hands on and collect a lot of data, we can do, and then we just need to make sure it's a vector, and then a neural network will solve it. And so, we made everything into vectors. Images, image patches were vectors. You can combine those and classify and parse natural language scenes. You can understand the structure of sentences. You can also map entire graphs into a vector space. This was a knowledge-based completion task where you have a database, and you just map every table into a vector and every entity in that database into a vector. And then you can actually start to classify, and you can see things like, okay, cats have tails, dogs have legs, tigers, are a type of cat, legs are types of limbs. And then if your database was missing some information, you can just ask the model, well, do you think there's a relationship here? And a Bengal tiger is an instance of tiger. Now, does a Bengal tiger have a tail? Right? And you don't have to manually define all the logical rules of your database, but all of a sudden, you can just let the neural network define all of these relationships. So once everything is a vector, you put it on the neural network, including things that don't feel like vectors, like databases. And I'll get back to that a little bit at the end, but the most interesting thing that could be a vector is an amino acid or a protein. And everything you've seen about ChatGPT, which is basically a large language model that maps every, not quite words, they're usually tokens, like sub strings, often words if they're very common. And then the main idea of a large language model is to predict the next word. It's a very simple, very powerful idea. And you might wonder, like, how could predicting the next word lead to something so incredible like ChatGPT? And how does it actually capture knowledge? But this idea of predicting the next word is extremely powerful when you do it billions and billions of times on the internet, right? So imagine I have a sentence, I'm in Dresden, and I'm getting into my car to drive west to. Now, in order to say what's the next word in that sentence, it's helpful if you have knowledge of geography and you know, like, Leipzig is west of Dresden. And if you're, in Berlin, you're driving south to, like, maybe it's Dresden, right? And so, but then it's also based on, like, it's more likely to drive somewhere if that city has more inhabitants, right? And so before you know it, just predicting all the words about, the next word and all the sentences that you read online about geography makes that word, that neural network, all of a sudden ingest knowledge about geography. Now, humans know geography, right? We defined it. But humans do not know how to predict the next amino acid in some weird sequence, like YMIQE, like what comes after that? I don't know, right? But to a neural network, it's the exact same thing. It doesn't matter if those are English words, programming words, or amino acids. It will just learn to predict the next amino acid. And so the same idea that powers large language models to answer questions in natural language, that same exact idea can be used, and we used it in 2018, to predict new protein structures. And then we actually went further and synthesized those. This was at Salesforce Research. A lot of people asked, why does a CRM company need to generate proteins? To which I always asked, why does a search engine need to fold them with AlphaFold? But it's a side story. We just did interesting research, as long as some of the AI also made it into the product and was working. But long story short, the same way these models understand English and German and natural language, they can understand the language of biology, which is proteins. And that hasn't had its ChatGPT moment yet, because biology takes a lot longer to iterate, right? You need to do wet lab experiments, it takes forever to generate something in the real world. You need to test it. You need to check if they actually fold. They do fold. It's pretty incredible. And then, if you actually want to run this in a human trial, it'll take, another 5 to 10 years. But in the next 10, at most 15, 20 years, I think this line of research will change all of medicine as we know it. And actually, just last week, the first author here, Ali Madani, he eventually started a company called Profluent. And Profluent just released their first open source protein. It's called OpenCRISPR, and it's essentially similar to CRISPR-Cas9, a protein that can change DNA in a living human being. And imagine you have like a genetic disease. You'll be able to just take one pill and not just deal with all the side effects of like sickle cell disease or something, but you'll actually be able to eventually just be healed from that genetic disease. It's truly incredible what this line of research will unlock, I think, and we're just starting to see the first inklings of that. But everything is a vector. Proteins, genes, they're all vectors too. And back then, the first thing we did was just looking at the energy, and we've seen that progen-generated proteins had much, much better energy values than random permutations. And just to put this into perspective, Frances Arnold won the Nobel Prize a couple years ago, I think 4 years ago or so, on what she called directed evolution, where she would take a protein, and it's just these sequences of amino acids, and she would randomly replace one of the amino acids with another one. And then she looked into it and tried to say, well, does this new protein that I just randomly permuted, does it work better along some dimension? Like it can still do a chemical process, but at a higher temperature or different pH values or something. And then she basically, after each random permutation, tried it again experimentally. And then after hundreds of them, she would find some proteins that actually work better to do a chemical process or biological process. And she won the Nobel Prize for that work, very well deserved. And the proteins that she came up with were 3% different to naturally occurring proteins. This line of work has now created proteins that are over 40% different to any naturally occurring protein. And they still work, they still fold, and they actually like function in space, which is a pretty good indicator that these kinds of models have understood well enough the language of proteins. But let's go back to natural language processing. So we have word vectors. Those are great. We now know everything's a vector. But words never appear in isolation, right? You want to have vectors also for entire sentences. And this is actually a pretty contentious idea. About 7 years ago or so, I literally had famous professors in the field of natural language processing, even a couple years before that screamed at me with their heads red, how it never will make sense, it will never work, and it's a useless direction, and so on, to try to squeeze multiple words into one fixed vector representation. And they just thought it was so fundamentally flawed. They were really, really upset that I was working on it. But it was working. You have experiments in computer science, unlike in some other fields. We have ground truth. You can look at, run an experiment, and if it works, then it works. It's hard to argue against that. And so we kept pushing and tried to now pre-train vectors in a context. So contextualized word vectors or full sentence vectors. And the idea was that you basically have not just word vectors, and then for each model you train a different encoder and everything, but you actually have one encoder that you can use for all the different tasks. And we're very excited. It worked pretty well. That line of research was very popular. We called this CO for contextual vectors. The next follow-up work was ELMO, and then BERT came out, and BERT was very, very popular also. And all of this, and sort of last slide, you already said it, I'm going to say it again. We worked on this paper that was the culmination of all my intellectual efforts for like 8 years. And that was to train a single model for all of NLP, which 2010, when I first had this idea, was absolutely ridiculous, and then it became a little less ridiculous every year. And then I thought in 2018 it was possible. And so we, and I say we, the first author here is Brian McCann, one of the most phenomenal human beings in the world. He's also my CTO and co-founder now at U.com. He was the main person who did most of the coding, and it was very hard. It took us over a year. And in computer science, generally, most people want to be able to publish like 3 to 4 papers a year. So I pitched this idea many times to many other very, very smart people, and they always said the same, which is, Richard, is unrealistic. I don't want to work on it. Give me another project that makes more sense, that I can submit a paper in 3 to 6 months and make progress in my career and so on. To Brian, it always made sense. He actually had a philosophy background and became a brilliant computer scientist. But to him, it all made sense. And so what we did was basically to cast all tasks as a question-answering problem over some kind of context. And that seems like similar to just predicting the next word. It's a very simple idea. But at the time, there's basically every state-of-the-art model was one model for one task. You wanted to build a sentiment analysis algorithm on Twitter, you trained that. That was its own set of weights, and maybe you started using word vectors, right? And then contextual vectors. But you trained a different classifier on all of this. Then you wanted to build a translation model for German to French, you trained one model for that, and so on. And we said, well, if we want to pre-train everything so that at some point we can have one AI model that kind of solves all the problems in NLP and vision and other things in the future, the task has to be also an input. It can't be something outside the model and you change the model based on the task. And so that was what we did. We basically said everything is going to be in the same format, and the format is it's a question, some context, and an answer. And everything is just a sequence of symbols, just words. And it was basically the idea the first time that you had what we now call a prompt. So you can ask, what is the summary of this paragraph, and that's the summary. What is the translation from English to German, and that's the answer. So everything is just a sequence comes in, another sequence comes out. And there are two specifically, we still separated those sequences out as like the question, which is essentially the task. So all of these things I mentioned earlier, is the sentence positive and negative, sentiment analysis is now just a subset of this model that we train once. And this is kind of fun for the database folks, you can also ask, what is the translation from English into SQL, right? And then you get SQL code out. So it's like programming code generation based on asking a natural language question was just one of the 10 different tasks. We called it the decathlon for that reason, which just chose the 10 hardest tasks in NLP. And this model was pretty complex. It was a pretty big beast. This was 2018, and for those of you really deep in NLP, you know that this was also the year transformers came out. Transformers, of course, are the T in GPT, generative pre-trained transformers. And the paper was titled, "Attention is all you need." And as you can see here, this is attention, this is attention, this is a type of attention too. The main, and the reason why that paper, the transformer paper, was called "Attention is all you need," and the big breakthrough was that they realized you didn't need this one here, which is a recurrent neural network, and recurrent neural networks don't work very well and aren't very efficiently trainable on GPUs. And so the main idea of attention is all you need is you can drop this part. But a lot of these ideas of attention mechanisms being very powerful were already out for a while. And so we trained this model, and it actually worked on all these different tasks. For some of the tasks, it was even state-of-the-art. And I was so proud and excited and very motivated. And we submitted this paper to ICLR, International Conference on Learning Representations, which actually has all of its reviews publicly available. You can still find this online. And so we submitted it, hoping maybe we'll get a spotlight paper or like an oral presentation or something. But those were the reviews that we got back. Basically, the reviewers totally thought it was misguided and overcrowded. We had too many good results. That was a problem for the reviewer and the famous anonymous reviewer number 2. And I'll actually have this up, and you can find this online. This is the actual website where you can see it. And it's just, some of it is really funny now. The area chair was absolutely certain that this paper should get rejected. And then the famous anonymous reviewer number 2, where is he? He said this paper was misguided and overcrowded. And the best part was he's like, question answering is not a unified phenomenon. There is no such thing as general question answering, not even for humans. To which I asked, do you replace part of your brain every time someone asks you a different question? Clearly, we have one brain that can answer a lot of different kinds of questions. That one brain can reason about math and reason about the velocity of a raindrop. Anyway, it's it's kind of funny in retrospect, but at the time, of course, it was kind of soul-crushing, to be honest, because we worked on it for over a year. Brian, trusted me. I told him it's going to be a great project. Trust me, it'll change the field, and so on. And then the paper was rejected. So it tells you something about having to have grit as an academic, and maybe sometimes you have to stick to your guns, because obviously the idea was very useful, and fortunately, because it was all in the public domain, right? The paper wasn't rejected from a journal and no one could see it, and read about it. The paper was public, and it did inspire a few other people to start doing more work in NLP, and to really realize that you could have a single model for all of NLP. And those people were especially Alec Radford, who later told us this, and Ilya Sutskever and a bunch of other folks at OpenAI, who, when they're still publishing papers, basically wrote in their first GPT-1 and 2 paper, as exemplified in McCann et al., language provides a flexible way to specify task inputs and outputs, all the sequences of symbols, go through some of our examples in the paper, and show that it was possible to train a single model for all of this, the multitask question answering network. And then OpenAI started shifting after this paper away from robotic hand gesture recognition and Dota game playing and so on to more and more NLP. And so we're like, well, we didn't fully convince it, and academically that paper, it has almost 1,000 citations or so, but it wasn't our best, most cited paper, but it inspired people, and then the rest is of course more well-known history. They kept running with this idea. Everything is a prompt now, everything is context, everything can be trained in those sequence models. And so Long story short, this was all in 2018, the protein model, the first model that can solve all of these different tasks in NLP. And then I thought to myself, well, if I can get an answer to any question from a single neural network, what's the most useful thing I could do with that? Where do people ask the most questions every day? Billions of times. It's what we now call, or used to call still, a search engine, right? Like that's where people go. It's kind of the entryway to the internet, the entryway to most questions. And again, 2020 felt like a repeat of all those rejections because most venture capitalists were saying, no one cares about search. Search is irrelevant. Like you will never beat Google. You can't do anything. Google invented their transformer. Why aren't they going to do this right away? But the truth is, Google is stuck in an innovator's dilemma, right? It's very classic. They make over $500 million a day in revenue by showing you ads on top of a list of blue links. And if you make $500 million every single day, you don't want the world to change. You don't want to give an answer to everyone for any question they have. You just want to continue the way you're doing it, right? And so we started, and there had been very little innovation. Started in 2020, and then in early 2022, we started adding more and more LM stuff to the list of blue links. We actually tried to innovate outside of blue links, but until ChatGPT came out, most users said, I'm so used to it. I want the list of blue links kind of thing. If it's too different, I don't know if I like it. So we started adding, essay writing on the top of the blue links, started adding code generation on top of blue links. But then fortunately, image generation, all of this generative AI stuff we added before ChatGPT came out. But then once ChatGPT did come out, finally users are like, wait a minute, I do realize now I could just get an answer. And wait, why am I still searching on Google if that's possible? And so as soon as that happened, we were the first to then connect our whole search engine into an actual large language model. And that would allow us to basically be up to date. Because as you all know, ChatGPT, you cannot train a large language model every 5-10 minutes. And even if we had more machines and so on, it would just be not feasible. And so what the internet connection for an LLM enables you to do is essentially to give citations. So if I ask, tell me the latest California news or something, then it will actually show you citations, and you know where those facts come from. And the main underlying idea here is that an LLM can be told to have the option to use tools. And one of those tools can be, if you can't find the answer and you don't know the answer, please do an internet search. And if you find information on the internet about that question, then use those facts from the internet to give an answer. And what's interesting is hallucinations can still happen in these models, especially when they're not connected to the internet. And some people say, look, like Microsoft, Google, they'll all crush you and they'll always be better. But I'll show you a bunch of examples where surprisingly, even a small company can build more accurate AI systems. This one is a particularly sad example where Microsoft, a Microsoft-powered chatbot, actually worked for the city of New York and allowed people to basically get answers about various questions, like if you're a landlord. And one of the questions was, do landlords have to accept tenants on rental assistance? And then Microsoft chatbot said, nope, you can totally discriminate against poor people. It's totally fine. But it is actually illegal in New York to do that. And the reality is different. And what's interesting is we didn't get a bunch of money from the city of New York at U.com, but we just have access to the internet. And we asked those same questions to U.com, and actually correctly cited the New York City government website and gave people the right answer. And so I'll show you a bunch more examples now. It's actually kind of fun. This one is part of our research mode, which will write very long essays. I kind of jokingly said, did we solve the hallucination problem? Right? This was Reddit S1. Reddit is about to go public, be publicly traded on the stock market. And it basically gave tons of citations for every single fact that it wrote. And then someone said, well, let me do a quick fact check, and I'm going to use Google Gemini to fact check if U.com was correct. And Google Gemini actually wrote right here that one of our facts, the number of active communities, was not accurate. And it thought, you think Google, they know, it thought that based on these metrics, it's actually 1.5 million. However, we had all the citations, so the user could quickly look it up and actually realize that, no, we were correct, and Google was wrong in the fact check of us. Very interesting. And again, all about citations. And I think that's also something that's really important. I'm seeing now some people already getting disillusioned and say, oh, these chatbots, you can't trust them, they just hallucinate, it's an unsolvable problem. Most cool, like for each new technology that comes out, you can think about all the problems it has and discard it. And to be honest, when I was still in Germany, I did the same thing. When the first iPhone came out, I was like, I'm a haptic person, I'm gonna need a keyboard. I'm not gonna be able to not have a keyboard. And nowadays, I'm trying more and more to just kind of downplay my somewhat German skepticism and just be like, okay, no technology is perfect when it first comes out, but you can always improve it, right? And when you solve like some of its problems, really interesting things get unlocked. And so another problem actually was that a lot of times, like as much as I love language, language isn't the best way to answer every question. Sometimes when I ask for stock price, I just want to see a stock ticker. And so instead of showing you some slides, I'll just show you now some real examples that I think are kind of interesting and show you, how to fix problems. So one problem was stock prices, right? I asked the AI, what's the stock price? Even if it finds the number is outdated every minute, right? The stock fluctuates. And so the best way to answer a stock price question is to just show you a stock ticker inside the chat. But then you can continue to say, oh, now who's their CEO? And as an NLP researcher, this is actually kind of an interesting problem, because if you just ask who's their CEO, you're like, of what company, right? You need to understand the whole context of that query. And so to show the right web results and so on, and the right answer, in this case, Mark Benioff, like you actually have to understand the context, and there's still a chat element to it. You can now, if you ask for restaurants, you can get an actual map, like all of these kinds of simple things. But where it gets really interesting, and I think really changes research, and it's sort of one of the steps, I think, towards the Eureka machine, which I'll get to in a bit, is this, what we call research mode. And so here the question was, explain the background, action, and consequences of the Peloponnesian War, which is an ancient war from like 2,500 years ago. And the answer that research mode gives is essentially a customized Wikipedia article that will talk exactly about the actions, consequences, of the Peloponnesian War. And so what's interesting too is for every single fact here, you see one or two citations, right? And you can go say, well, did this battle really happen in 405? You go to the site, and not only will it just say somewhere on the site, maybe this fact was mentioned, but it actually scrolls down, and in all Chrome and Chromium-based browsers will mark exactly where it found that fact. No LLM does that right now. In general, generative AI is only as helpful as the time it takes you to verify if its content is correct. Now, the next level, and one of the biggest problems of LLMs, is what Daniel Kahneman called thinking fast and slow, or system 1, system 2 type reasoning. Now, LLMs are clearly good at quick, snappy answers, but they're not very good when it comes to actually logically and mathematically reasoning, which is a little bit sad, because in the process of generating an answer for you, it actually does billions of multiplications, right, for very large neural networks, but it still won't give you the correct answer to a simple multiplication problem, unless you allow it to program. And that's what we've done in this genius mode, and we're one of the first to connect an internet search capability plus the ability to program. And all of a sudden, it unlocks a whole nother set of use cases. So here, and this is a fun one, if you're still mathematically inclined, you can try to solve this problem right now. I'll give you a few seconds. I'll read it out. There's a Ferris wheel, Riesenrad, with a diameter of 60 meters. The center of the Ferris wheel is 40 meters from the ground. And then when someone starts on the Ferris wheel, they start at the bottom, and they get in, and then it takes them 4 minutes to go all the way around. Now sketch a graph to show how the height of the passenger varies over time for 8 minutes, right? Now you'd be like, okay, like start somewhere here, or how high is that? They go up and down, and basically this model now, in the genius mode, will think about a couple of different things, realize, okay, you want to show a graph, I'll probably have to start some programming, and then it will actually translate all of that natural language math question into Python code. And then, and this is kind of a security nightmare, we allow arbitrary AI-generated code to be run on our servers. My security engineer was not happy about the decision to ship this feature, but so far so good. And then it actually gives you the correct answer. It's just kind of incredible. I was wowed myself. My CTO said, "Oh, my sister was doing like some homework, and like she was like, it just worked." And then you can still, like, ask it all kinds of follow-up questions and like explain why the graph looks like this and why is it half offset and so on. And I'm like, okay, that's amazing. And I actually showed this a couple of weeks ago to a friend. He's like, yeah, but like ChatGPT could probably do this too. And I was like, well, let's take a look. And this is ChatGPT, and you ask the same Ferris wheel. It's exactly the same input, and this is the output. And it is not a Christmas tree that goes to 100 meters. Let's just say that. And likewise with the Peloponnesian War question, you can get a lot of facts, and some of these are correct facts, but you have no idea where they come from. And those websites also don't get any traffic, which is a different, financial problem, less of an invention problem. But you just have no idea how to verify any of these things. So now if you really care about the accuracy, because your grade or your job depend on the accuracy, now you have to basically put each of these sentences into the search engine and verify it, and then that takes a lot of time. So it's not very useful. And then that was ChatGPT. Now they said, well, but you'll never be Google. So we asked Google Gemini the same question. Exactly the same input. This was its answer. It's slightly worse. It's not even any kind of resemblance of a curve. And then we asked Anthropic, also a $40 billion company now. That was its answer. Goes backwards in time. Kind of doesn't make sense either. So it's kind of interesting. I don't know. And I hope this, it's partially, of course, I'm proud of the product we've built, but I hope it shows you that you can really build something in a small team. We're not that large. I mean, we've raised $45 million, but we didn't raise 10 billion like OpenAI had. And so we can still outperform them. And just to get you a sense, if you're a knowledge worker or a student and you need to combine information and then do computation on it, there's just an incredible amount of cool things that can happen. Like you say, find the population of these two countries and then plot it, assuming some growth rate, and again, translate it, goes on the internet, finds information, plots things for you. And this is very interesting, we're now getting more and more biotech companies actually who are starting to use this in their actual workflows. So here I had a friend works in the healthcare industry. I fortunately don't know what an EGFR positive lung cancer is, but he just said, oh, Richard, look, type this in. And I can verify most of these things, but he was like, wow, this is actually all correct. And again, here, it says this cancer is more prevalent in people of Asian ethnicity. You click on the citation, and there it goes. European magic here. This does not happen as pop-up. And then, you get exactly, it marks exactly where it found that fact. And if you, trust medical news today, then you can trust this fact. And then it's interesting, you can say, well, but I'm a legit researcher. I only want to know these results from Nature journals. And then, most of the citations are actually from Nature journals. So have some inhibitor thing here, go in, and there it is. And it's actually only using Nature journals. Of course, only those that are publicly available, unfortunately. We don't have access to all the stuff behind the paywall. But yeah, so that's basically, even for research, you can use this technology. All right, we can skip demo time. Oh, I'll just do one more. This is a kind of fun and kind of sad one at the same time. The question is, what should the initial investment in a compounding interest index fund for my 1-year-old child be to ensure that it fully covers the cost of her Stanford tuition by the time she completes high school? If you're ever an NLP researcher and you used to think about logic and how to map, back when I studied linguistic computer science in Leipzig, I did this thing called formal semantics in linguistics, and we tried to define rules of oh, he's strong like a lion, so you have a list of human-defined features, lions are strong, and he's projecting that. If you try to think all the things that are going on to get this sentence and this answer right, is kind of mind-blowing, right? Just like, how long does it complete high school if you're 1 year old in this country? Like, how much would a compounding interest index like make? How much does Stanford tuition cost? What about by the time she as in that gets more and more expensive too? All of these things. There's so many logical things you need to now go on past Google to search for and to get the actual correct answer. And in the end, after doing multiple different research, thinking, programming steps, and going and finding all the different facts and how much approximately undergraduate programs are costing and how much that increases and interest rates and so on, it actually puts it all together, and it would have to be a sad $37,000. You get it for free at TU Dresden, but Stanford, it'll cost you about $37,000 after many years, and then all the compounding interest and so on. So really exciting. We're scientists still, so we don't just say, oh, here's some fun anecdotes. We actually ask other people that evaluate answers, and indeed, in these third independent party studies, we are more accurate than even ChatGPT 4, which is the premium paid version of ChatGPT that you pay $20 for, and you pay $20, actually $10 if you're a student discount, and even fewer probably if we figure something out here. Evaluators, basically, we classify all of these different things: clarity, comprehensiveness, conciseness, factuality, faithfulness, and so on, of these different systems. And even ChatGPT 4, these are the actual numbers. And we don't win everything, right? This is not like a fake marketing study. It's like a scientific study. And on comprehensiveness, we are almost twice as good as GPT 4. This one, I think, is the most important one, or more than twice as accurate in terms of the accuracy. But we are not quite as concise as GPT 4, and we're similar in terms of clarity of the answers, and just slightly above in terms of actual user preference. I'll stop there, but there are lots of other examples, like NVIDIA stock. We asked GPT-4 plot the NVIDIA revenue for the last 5 years, just made a bunch of numbers. I actually was talking to Jensen about this, and I showed him this, and he's like, could have been, but NVIDIA did not go down last year, let's just say that. $2 trillion company now. We also had to build a whole new index of the web. Basically, all current indices of the web are built with people in mind to decide which of the blue links to click on. So you have very short snippets, but LLMs can index and ingest a lot more content and then give you better, longer answers. Now, that's sort of the past, the present, and now the future. And I think the future is going to move from having foundational models of language, which again, 10 years ago, sounded really ridiculous, and even 6 years ago were rejected in conferences. But I think we can now start to think about foundational models for science, like Naturwissenschaften, like physics, biology, chemistry, cells, organs, organisms, and beyond, like human systems, and so on. And this, of course, was an image created by you.com too. Short side note there, just a fun visualization for that slide. And you might say, Richard, that's crazy. And it is impossible right now. It will take 5 to 10 years. But imagine what will get unlocked if you can have an AI scientist that will just do research for you, will never sleep until it solves some kind of problem. It will, again, change all of humanity. And the first signs of this being a real possibility are there. I'll just give you one example. There are literally thousands that you can find online. Physics, chemistry, biology. In physics, AI, deep learning, and reinforcement learning have now been able to contain plasma in a tokamak fusion reactor much, much better, so you can actually get closer and closer to having really stable fusion reactors. In chemistry, it's actually a result from Google DeepMind. They were able to build millions of new types of crystal structures for new kinds of batteries. We have infinite energy from the sun, basically, for all human purposes. We just can't store it at night and so on, so we need to have better batteries. AI will help us with this, and this is a big part of climate change, so AI will also help with climate change. And of course, in biology, we already mentioned this example of being able to create different kinds of proteins, and that is getting more and more scaled up now. And here's just one other fun paper. I was not involved in this paper at all, where basically what they did is they built these carbon nanotubes, and on one side of the carbon nanotubes you put an iron molecule. On the other side of the carbon nanotube you put a protein, and you manufactured and designed that protein to only bind to brain cancer cells. Brain cancer cells have specific types of molecules, and you can structure and design these proteins to only connect to those kinds of cells, only connect to cancer cells. And then what these researchers did was basically to put the mouse into a magnetic field after injecting all these carbon nanotubes. The carbon nanotubes, after getting injected into mouse brain, attach to each of the cells of the brain cancer. And then they put the mouse into a magnetic field, and they spun all the carbon nanotubes around. AKA, they created a cellular level scalpel to just destroy the brain cancer cells. When I saw this paper, I don't know, like oftentimes I read papers and I'm like, that's pretty cool. But when I saw this paper, I got almost like giddy and happy. It's just like, it's so cool. It's so incredible. Now imagine when you can design other kinds of proteins, right? You have, some plaque, Alzheimer's in your brain, you have some like fat in your vessels, and you could eventually inject arbitrary dyes, and then they will just like connect to exactly what you don't want in your body, and like you have a scalpel now that's just like scalpels that one thing away. It's just, I mean, the future of medicine and us as humans is going to be incredible. We're going to be able to live longer. It's just amazing. But there's one big thing missing. When we can train models to understand human language, then really we can just use human language as training data. But when it comes to science, we actually don't have the language of all of nature already here as a nice data set on the internet, right? You actually need to allow an AI to have access to simulations. And by simulations, there's simple examples. For instance, Go. Here's another example. I'll go to the simple example, the more interesting example first. Namely here, what we did, and this is sort of goes even higher level than biology, aka systems of humans working together. And the idea of this simulation was to have people, they have AI agents, very simple approximations of people. But these AI agents have a utility function, and basically they get to build houses, collect resources, and then they want to maximize their own utility. It's sort of a built-in assumption. You can change all of these assumptions, of course, that people mostly want to work for themselves. And now you also had an AI economist that would set this taxes and subsidies of all these AI agents running around in their simulation and trying to do what they want to do. And this AI economist was told, you should maximize the product between productivity and equality of the system, right? You don't want only equality, because if you're all dirt poor, that's not great. But you also don't want just productivity and one person owns everything, right? So a mix of these two. And the AI economist would basically go and say, all right, you get taxed this much, you get those many subsidies, and you can now run basically billions and billions of years of taxation, right? You don't have to fight over it. You don't have to start wars about what's better, this or that. You can just like allow an AI to learn from billions and billions of years of other AIs trying to do whatever they want to maximize their own resources. And indeed, some of the AI agents found that if they block all the other ones with houses, then they have all the resources to themselves, right? But then they would get taxed more and more. And just to give you a sense, like this Saez model is a very famous I think Nobel Prize winner too in economics, Berkeley professor, and this is like one of the most well-accepted models for the economy that has actually influenced real policies. And that model is beautiful because it's provably correct for a one-step economy. But it turns out people adapt. They don't just do one thing once and then that's it for the rest of their lives, right? And so this AI economist, the reinforcement learning and deep learning approach, basically could use simulations to find better taxation structures. And instead of waiting and seeing how people will complain and so on, it could try it billions and billions of times. right? Now, this one, I think humanity and certainly like identity politics and so on is not ready for it. So let's go to a simple example, the game of Go, right? Any problem that you can simulate and that AI can interact with billions and billions of times will be solved with AI. It's a pretty foundational statement. And you can think about all the things we could simulate, and it'll be pretty amazing. And why do we need to simulate? Because like even just the example of Go, there's this famous move 37, and that the world's best Go player was like, wow, this is like beautiful. I wouldn't have never come up with this move, but the AI could, because the AI could play billions of times against itself. Now Go, despite being like computationally and complexity-wise pretty complex, and there are more Go positions than atoms in the universe and whatnot, it is fairly simple to simulate, right? We know all the rules, we see everything that we need to see. What will be much harder is actually to move from simulating games to simulating things like cells. Now, once we can simulate cells and multiple cells together, all of a sudden, there's just going to be an amazing explosion of what AI will be able to do for us. Because now AI can try billions and billions of things and experiments even faster, right? If you don't have to have a physical experimentation loop, but you can have a software experimentation loop, all of a sudden, these various little robots, quote unquote, that are walking around and transcribe genes and so on, will be able to modify and try out and have them, solve new kinds of problems that we currently can't solve. So that's basically my final kind of invitation here to a lot of you. I think actually Dresden in particular and Germany is very, very strong in the sciences, in physics, chemistry, and biology. And I think in the next 5-10 years, we're going to automate a lot of digitized jobs. It makes a lot of sense. We'll all be more efficient. Companies will run better. We'll get more efficient answers. Researchers will get answers more quickly. Don't have to spend as much time researching existing things and can spend more time thinking about new things. But eventually, if we can unlock an AI that can automate even the identification and experimental validation of hypotheses, it will just massively unlock things. And what we need to do is not just have a deep foundational model of natural language, but eventually for all of science. And then I'm long-term extremely optimistic and very excited to have many of you in the room here hopefully work on these things. All right, thank you.
Yeah, thank you, Richard. Great talk. And we have time for questions. And Richard is around with us. So off we go. And I think that was the first hand over there. We have some mics in the room that will come to you in roughly some seconds. Or you start already. We have a question over here. OK, start there.
Okay. Do you think that we will get to this point that the AI model questions itself, so that it's like an ongoing research because it finds new problems?
Yeah, so the question is, will the AI question itself and come up with new hypotheses? It wouldn't right now. For the most part, all of these large language models, for instance, they're just trained to predict the next token. So if you give it, here's a hypothesis, now find me another similar hypothesis that's slightly different, it will do it. But it won't, like, right now, nothing in the AI will get it to want to do anything itself, right? You prompt it, and it will do it for you. And there are some fears of people saying, oh, the AI, it's getting so much smarter, it will take over, right? It will have a mind of its own. The truth is, no one is working, no company is putting significant resources behind an AI that does whatever it wants. Why? It's like training an employee for 20 years, spending billions of dollars, just so that employee can then say, well, I don't want to work for you. It's like, well, that doesn't make that company any money. If you have an AI that does exactly what it wants, maybe it just wants to go to Venus and explore, or Saturn, explore some interesting new atmosphere problems, right? And then you spend all this money as a company having an AI that does what it wants, and now it doesn't want to do what you want it to do. And then, so because no one is working on it, we don't know when AI will truly become conscious and self-aware and set these goals. But I do think when you give it a goal of saying, here, like, solve this problem. Like, there's this virus, it keeps going into the cells, but you can't just block it, because then you might block some other processes that are also needed for a healthy human. Like, now just like make it so that this virus can't get into any of the cells, but you know, all these cells can do everything else still that they did before. Now try whatever you can. Then I think those kinds of models will find tons of different hypotheses to try to get to that goal, and they will start to think outside the box, because they can just do it billions of times, whereas humans can only do a few real such experiments.
First, I want to thank you for the great presentation. I really enjoyed it. And as an economist, I was really intrigued by the simulation of the island and the little people with the productivity and taxes. So my first question when I saw it was, who decides what's the utility function? Because the utility function you use determines what's the optimal simulation will give you out. And also, I don't know if you know about the gender data gap, but for example in medicine, women are really underrepresented in research. So how is AI also ensuring that these biases that we humans have is not transmitted into AI and reproduced or even exaggerated there?
Yeah, the bias question and the objective function. You know, it's really interesting right now. I feel like in politics, often people say, this is what I want to achieve, and here's how I'm going to do it. And you just kind of have to trust them. And, you know, and like there's some high-level goals of like some people in the US believe in trickle-down economics. We just make the rich people so rich, they'll just like create more jobs. And so we tax them as little as possible. And then good things will happen because bigger companies have them give more jobs that way. And then there's some people say, no, we should do the opposite, tax the rich like crazy, you know. And like what's interesting is we can all agree, I think, more easily on the outcome we want. It's not like people say tax the rich in order to make the rich richer and everyone else poor. They claim to say we're going to tax the rich so much in order for everyone to be more wealthy, right? But maybe there's like subtle balances, right? Maybe there's like subtle differences. And so I think it'll be nice to say, here's what I want to do, and now let's have an AI try billions of years of that plan that I came up with and see if it's actually better than maybe another plan that could also work to achieve your said goal. And so ideally, of course, if this ever gets implemented in the real world, lots of checks needed. I hope this will not get implemented next year, right? It would need a lot more better fine-grained simulations. But the goal would be for people to agree on what they want. Each country will decide which, what their objective function should be and how they want to live as a society. And then we can hopefully get some inputs, at the very least, from an AI. Maybe we don't let the AI decide by itself, right? There should probably be some people involved. But at least we can get an input, and we can test out whether the things that the politicians actually propose have any chance. In any of the billions of years of taxation, did that ever work out the way they said it would work out, right? That would be very powerful. And at the very least, in economics, from my limited understanding, other than like in this work that we've done, a lot of economists like work with very simple linear models and very simple assumptions about people that don't really update. At least if you give these simulations that they use like some intelligence and some ability to adapt and train, will come up with better, more accurate models of economics. And then we actually had another paper here that was a follow-up paper where we added productivity, quality, and sustainability. Right, so that it's not just like you can get rid of all the resources, people are pretty equal, and you have massive productivity gains, but like 20 cycles later, there's no more trees, right? And now it's over. And so you can add, and every country should eventually decide like what they want to add to it, and hopefully they can work together. And we actually had one simulation too where it's multiple countries trying to identify best ways to achieve sustainability. There's like tons of interesting research that can be done, but this line of research, one of the reasons I brought it up is that it hasn't had its sort of ChatGPT moment either. Economics is a very old field, and unlike in computer science, you just can't provably say, look, it works better on all the benchmarks, right? And you're just like, there's a lot of, for better or for worse, like opinion and politics in it. So this field could still, use a lot more AI. And then the bias one, is a good one too. Try to keep it short. Could talk a long time about bias, but AI is kind of a new hammer. It's a new kind of technology, like computers, like the internet, very generally applicable and only as good as the systems, the people, and the data sets that influence it. And as such, it will pick up those biases, right? And it's actually really hard sometimes to fight those biases. Sometimes it's easy and sometimes it's required by law, fortunately. Like you can look at past who got a credit line or a loan for a business, and if you allow the AI to look at gender and you don't see as like historically as many women starting their own business the way my mom did right after the wall came down, then the AI would discriminate against women from getting a loan. Now that's fortunately legal in almost all the countries, and so you just have to take that out, and then you have to also be careful about not having first names, because that could be another way of getting to the gender and whatnot. And so there are ways to fix it if you really want to. And then there's sometimes questions of how much do we want to show the world we would like it versus the way it is. And so there's this famous couple of examples from Google where you ask the Google algorithm like to give you a picture of Nazis, and a picture of the founding fathers of the United States, and it basically gave you pictures back of 10 black people. And you're like, okay, it tried to fight the bias, because in the training data there's a lot more pictures of white people, and to fight the bias, it tried to create answers that have better distributions and more representative samples, but it was overshooting a little bit because there were no black founding fathers, right? And so, and then as a search engine, I actually ask this question myself a lot, and I feel like we have to err on the side of showing as a search engine the way the world is, even if we don't always like that answer. And so if you ask for like pictures of CEOs, I don't know if they can all be black women. Like it's just not the reality right now, right? You should have some at least, and it shouldn't be all just old white guys, right? But you need to kind of show the way the world is. And so there are lots of interesting, hard bias questions. Happy to talk about them a lot more after.
I have a question which might come across as a little bit of a fear question, and I know fear questions are boring, but it relates to your point at the start about jobs. Many jobs will disappear which are not involving emotional intelligence, but maybe just an argument that emotional intelligence isn't anywhere near as complicated as many of the things you've very cleverly demonstrated in some of your papers that you can solve. And if we take the example of medicine and Hippocratic AI, which I think are quite an interesting company, one of the first roles that they're looking to roll out in terms of agents is actually the role of like virtual nurses. And we saw in the US 2 weeks ago protests from nursing groups linked to Kaiser Permanente of some of the fear about the replacement of jobs, which actually involve a degree of emotional intelligence and maybe not the typical roles we would have expected AI to be threatening to replace. Are any of these fears founded? Could we even find the emotional intelligence jobs going?
Yeah, it's a good question. I have invested in 2 companies that I'm doing a bunch of sort of startup investing on the side of AIX Ventures, and one of the companies that invested in is a robots company that basically automates getting medication out of like a large basement cabinet into the exact right room for each patient. And a lot of nurses will complain about burnout, and this is one of the many jobs where it's not fun, you don't interact with a human, it's very tedious, and you just have to run around and grab the right things. Also, like 10% of all the really fun things disappear, and some of them are addictive. So it's like a huge problem. And most nurses, if you ask them like, hey, why do you go to nursing school? They didn't say, so I can run to the basement and grab the right 3 things and then run up 50 times a day, right? And so that, that company claims that they're actually making the nursing job better and will prevent all the like burnout that nurses have. Another company is working more with doctors directly. Basically, doctors spend a lot of time talking to patients, but then they have to spend another like 30% or so of their time writing out notes about what they just talked about with the patient, and then saying, okay, based on this, blah, blah, they have to fill out tons of forms and in their EHR, electronic medical records or health records. And they hate it. Doctors hate it. That's not, they didn't start like wanting to become a doctor in order to type up like bunch of reports, right? They already know what the problem is and so on. So what this company does is basically, everyone has to agree, then they record the full conversation, and then it just takes the entire set of doctor notes automatically, saving doctors 30% of the time. And if you ever had to wait for a doctor appointment, it takes a while, right? It's just like there are not enough doctors. And so it's AI in medicine overall is actually a really interesting question where more people probably agree that the goals of medicine should be to have as many healthy people as efficiently and quickly as possible, not to have as many jobs as possible, right? And so I think we will continue to need nurses. There's a huge nurses shortage. There's a huge doctor shortage. It's a brutal job, long hours. People are unhappy when they're sick. So it's like oftentimes not happy times, right? And so a lot of the companies that are trying to improve that I think are doing a good job, I think make the situation better. Now, again, nurses I don't think will get fully automated. There's so many, and it's actually a really complex line of work, right? And some of it will be about people, like calming someone down. It's much harder for an AI to calm someone down when they're about to get cut open and have a panic attack or something, right? I think there will be lots of jobs, and my hunch is in 10, 20, 30 years from now, nurses will be much more able to actually spend time with people rather than running around grabbing things from medical cabinets and stuff like that.
Thank you for this great and inspiring talk. So I actually thought about machine learning the last couple of years, and I worked a little bit in it, but I'm still an absolute beginner, and I would love to share my thoughts about the future of the world and machine learning with you to hear the opinion of an expert on it. So what I realized was that the fundamental thing of machine learning is that it matches one pattern to another. And so I thought about in my daily life, what jobs are just a matching of one pattern to another and therefore can be replaced. And I think when you think a bit about it a little bit, you see the obvious things, like a man or a woman stands on a line of work and presses something, so this can obviously be automated because it's an obvious pattern. But me myself, I'm a programmer, but I'm thinking about programming. Programming is also just a little bit or a more complex pattern matching. So I think this can be automated sometime too. And now with ChatGPT or with other large language models, we see matching from text to text, but we also see in other AIs matching from text to images, from text to video. So we see all these connections, and now with the robots of Tesla and Figure 1 and so on, we also see a matching from text or some input to physical work. And now we think about, okay, can all physical work now be automated also, because it's also some pattern from text to something physical. And so these are already a lot of jobs. And so my next thought was actually,
will there be a question too?
Yeah, I have a question. So my thought was, so what is missing? And what is missing is, what if AI can do science too? Because then it can also discover new things all the time. So, and now you had this talk. So what my question really is, when AI can do all this pattern matching, when it can do all the work, and when it can do it when it can do the research too, what will be left for humans?
All right. Yeah. Good question. I think think about past innovations and technology, right? The internet. Internet's amazing. Internet's been around for a long time. If you go to Brandenburg, there's still a lot of spots with no internet. I tried it. I was in Meseberg with the German Chancellor and the cabinet, and I was waiting, and I had some hotel close by, and there was no internet anywhere. AI is a little even more complicated, but even more powerful than the internet, and so it won't just happen all overnight, right? So that's number one. AI, yes, it will change jobs, but not all just overnight. There's a lot of examples where even in your first group, which is correct, which is input-output, radiology is a perfect example for that. Radiology, you get an image coming in, you're in a dark room, literally, and your main job is looking at screens in the dark and then writing out reports. And I actually talked to the radiologist of the year, works at the largest teleradiology company, and I had worked on various things with them. It's actually kind of a sad story. Maybe I'll skip it, it gets too long. But long story short, there is no really great AI radiologist still out there. Why? Because you can quickly build a classifier, come in, is this pneumonia or something? You get thousands of examples for pneumonia. We had classified one for intracranial hemorrhage, brain bleeds. But then a radiologist has to look at for thousands of other things that might be wrong. And it turns out there's not a single very large data set that captures all the things that are wrong in radiology. And it will take many healthcare systems and probably many healthcare systems of many countries, because it turns out women and men look different in X-ray scans and various other scans. Even Asians and white people look different in certain human anatomy and so on, and have also more prone and likelihoods for different diseases and so on. So you need to have massive data sets to really do that full automation. It will take decades for all the countries in the world to come together and have all their radiology scans digitized, working together, clearly labeled, and so on. So that's basically a long-winded answer of it will take a long time. And then you can say, well, but let's say 500 years from now, there could be more and more. And what's interesting here is that just like if I had been some steam machine or electricity researcher 150 years ago, I couldn't have told you that when 90% of people work in agriculture, they're gonna be these YouTube and Instagram celebrities, and you can totally make money being an influencer. I wouldn't have known that, and I couldn't have predicted it. I don't think anyone could have. And just like that, I can't tell you what in 150 years from now kind of crazy jobs you think will be around. But I can guarantee you that humans have a lot of ingenuity when it comes to making money and finding interesting things to do and jobs. And there will be a lot more base jumpers probably, and a lot more paramotor pilots, and people making amazing videos, because no one cares about a robot jumping off a cliff, but it's more interesting when a human does it. And there will be all kinds of fun jobs that people will come up with. And the most important thing is to understand how it works, understand what's possible, and then be creative in seeing those new kinds of problems and solutions. And I think for the foreseeable future, AI will just be the most incredible tool, but it will not just take all the jobs away overnight.
Since there's not yet AI working, please be concise in your questions, and keep in mind that we only have 5 to 6 minutes to go, so 3 to 4 questions.
I will also try. Be short in my answers. Kidding.
Okay. Okay, sorry. I also have a really short what's next question. You introduced the concept of interacting with an AI based on written questions. But there are a lot of new ways how you can communicate with an AI, like voice or even Neuralink. So what do you think about what's the future way of talking to you?
Yeah, it's really interesting. There are all kinds of fun, cool new devices. There's some various pins and so on you can do, to which my first thought was, I solved it. But I think language is a very powerful way of interacting with language, with AI and with computers. In fact, it's really incredible that one of the most popular programming languages very likely will be English, right? And that will unlock, imagine all the creativity that will unlock. Any high schooler can then build a new app and be like, oh, I want to build an app where we all select on a map where we are, and then we play whatever, something in the park, and then boom, there's a new app for that, right? It's going to unlock so much creativity. You're going to have natural language programmers, and that will be a whole new job, and maybe the first one that we just came up with together. But I think language will be the large one. We did also invest in one fun company. They basically look at the electrical signals in your jaw, and from that they can actually know what you're saying without you opening your mouth. So I can be like, and my tongue moved as if I said those things, but no one heard it, and it could actually write it out. So there's some fun things. Obviously, Neuralink is only if you're in a really, really suboptimal position in life. You can't move anymore. from the waist down, and so on. And then you might be willing to have a hole drilled into your skull and then have all those sensors added into your brain and so on. I don't think that will come anytime soon. But I am excited about more visual interfaces. I think at some point, VR, AR will probably happen. I think it's still like too clunky, too big, too slow. But you know, if you just, everything you see the eye sees probably will be illegal in all of Europe for privacy purposes, maybe sensibly so. But for some folks who want it, they can just like have the eye and just ask it a question anytime, sort of ubiquitously, and that will happen. But I think I'm bullish on language. I think it will continue to be the #1 modality.
You showed us the very interesting researcher's mode of U.com, but is there some kind of quality assurance when it comes to the sources? So for example, in this medical case, how do you assure that the information generated is based on medical guidelines or reliable sources like The Lancet, and not on on an amateur's blog post?
Yeah, that's a great question. So because we have control over the index, we are trying much harder to focus on the right sources. So you can actually see here, there's like, for this particular lung cancer, there's lung.org, bunch of UC Davis, like medical universities, and then there are various Biomed Central and like actual like cancer biology and bioarchive and such sources. So we can't like ensure it fully, because in theory you could ask, what does my astrology influencer say about lung cancer, right? Like, and we'll probably still give you an answer, right? It's just like, it's a tool, right? It's only as good as the people who use it to some degree. But it'll probably like give some warnings and be like, you should probably not trust it, but here's what they say, right? Which I think makes sense for a search engine, right? We don't want to be the arbiters of what information exists online. And so, but yeah, the default is you will get it, and then if you actually know the Lancet journal, and the problem is, of course, the kinds of things that a Nature journal would say are also not really understandable. Imagine you just got, you're a normal person and someone just gave you this, and then you just get this like answer, right? And you're like, oh, amino acid 747/75 accounts for 45% of mutations. Like, I have no idea what that means. So it doesn't always make sense to use medical journals. There's like a whole cottage industry of people trying to describe medical results for normal people, and those will come up too. But that's the beauty. Like, it's all in English language. You just say, well, I want to see those results from Nature journals only. And then it's not only, right, there are some things, but now all of a sudden, like, the vast majority of all the citations are coming from Nature journals. Sometimes it makes sense to write a cohesive article about all these different things. But it's also incredible because it realizes you asking for Nature journals will give you much more complex like sections like molecular reprogramming, pathway co-regulation, versus like in this one it'll be just much more like, here's some different targeted and combination therapies, and like it uses different language based on the skills and the language you used in your question, which I think is exactly where it should be.
So thank you. Is it on? Yeah. Your talk was about the Eureka machine. And if I got you correct, one of the missing features is providing access to models and simulations. So the AI needs to have access to existing models. And you already said that some of the models are not accurate and can be improved for the economics, for example. But parts of the innovation comes from inventing new models, I guess. And I feel like we're doing the same thing again. I don't know whether you agree or not. I'm learning about you. I'd like to learn about your opinion on that. But again, providing models per application area, isn't that the same thing as solving the problem over and over again? Does it make sense to teach AI mathematics as a general language to express theories and models and do own simulations rather than giving access to existing ones?
Yeah, it does. And interesting enough, that actually was a very hip area of research for a while. I had some papers in a tool called architecture learning, where we try to allow an AI to describe neural network architectures in a simplified language, and then try out different things and then run those experiments. Google did the biggest such papers, where some of my estimates was like that was probably $10 million of compute for one research publication, right? Because now you have an outer loop where you try a different network, and in the inner loop, you got to run it through like 10 different data sets and like fine-tune the model, blah, 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 and then like actually get the result, and then you make another small modification. You have to do that now millions of times, so it gets very, very expensive. And somewhat interestingly enough, like the transformer model, which people did come up with, who've since all left Google, because again, innovator's dilemma, they didn't really want to use the like research in their main applications of search. They all left, and that is still one of the best models. Of course, there are lots of little modifications and little improvements that people have come up with, but somewhat surprisingly, architecture search has not had its success yet, largely because of the lack of computation and the cost of it.
Two more final ones, Seth? Okay, and we go first.
After I learned everything is a vector today, and my background is in education, and I always think of AI and large language models from the perspective of learning. My question is, what is your view of what potentials have large language models for learning, and can they change how we learn? And did you ever consider that you is asking me some questions to get a vector of my concepts and to match it with the next best word, and that the next best word is the next best word for me to get to the next level of understanding?
Yeah, it's a great question. I actually do think like AI can totally be used in education. I just came up with one random quick example, which is like, write me some good quiz questions about the American Civil War. You just studied for it. Now you want to practice for an exam, and boom, it's just like, you just have to zoom in and not show the answer, and then you can get like a couple, like right away. Where was Abraham Lincoln assassinated? What percent of the military age Southern white men became part of the Confederate Army? Like, many, and like blah blah. So like, and even like some true or false questions, and you can say like, give me 10 more true or false questions, right? So yes, I think AI will change all of education. It's very interesting to see. We actually have several universities now that we're talking to about giving all their students access to u.com. And then we have, I've heard at least, of several universities trying to just ban all like ChatGPT, u.com, and so on, just make it illegal, and you automatically get a fail grade and so on, which feels very wrong, because if your parents use something in their job all day, and then you don't allow students to use it, they're not getting prepared for the work they're supposed to be doing. So I do think, obviously, testing has to change, right? If you want to test someone's actual ability to write an essay, it can't be a take-home exam. It has to be an in-class exam with no internet. So there's some obvious changes. I do also think that similar to, and I was, again, just in my high school earlier today, and I was one of the first generations who were allowed to use a programmable calculator in the math Abitur. And that changed, right? That changed the kinds of questions. You didn't just do like, oh, here's a simple quadratic equation, because you knew any amount of program. You could program like, here are the factors, boom, I get the answer out for any quadratic equation. So they had to come up with more interesting and harder math problems to solve, and they did. And it was really fun, and it was interesting, I thought. Maybe not everyone agreed. So I think what we teach kids will have to change. How we teach kids will change. A friend of mine, he was a professor, still is a professor in Berkeley. He had to do all this grading, and he had classes for like 500 or 700 students. And you have 30 teaching assistants. Stanford, Berkeley, these kids, they pay a lot, so they want amazing service. It was pretty stressful as a professor. And so he basically said, I don't want to spend all this time grading anymore. So he built an AI that grades anything in chemistry, physics, math, and so on. You can just type it. It's like handwriting. It will translate all the handwriting and then grade all kinds of homework. So I think company's name is Gradescope. And so I think there's gradescope.com. Yeah. So they will any kind of homework, exams, code, of course, even easier to grade, and then students can just put this together, and then it will get automatically graded, even with crazy stuff like this, right? And he just basically grades the whole thing. So again, I don't think most teachers, when they sign up to teach for 30, 40 years, realize that they're going to have to spend a lot of nights like trying to read this Sauklaue here. But that's a huge part of the job. I think it'll be a more interesting job for teachers if they don't have to do this many, many times. And again, any repetitive work, this is very repetitive. If you teach that exact math question for 10 years, you're pretty sick of it, right? And grading it is not going to add any interesting things to it either. Now, of course, once you have the grade, you can see how many of my kids failed to realize that the sine of 90 has to be less than 1. And then you can actually realize, oh wow, I look at all the stats and analytics, now I know I need to teach that concept better. So this is just one of many examples of how AI will change education.
Yes, maybe one last question about hardware. I'm sure that you know about hardware very well. What's your opinion about quantum computing and quantum computers for the next maybe 5-10 years? If we have real universal quantum computers, would be the next jump in computer power for AI?
I think quantum computers have in theory so much potential, but in practice, no one is programming for them very well right now. And even though we have a lot more, 100+ qubits now, I do not yet see a massive improvement for AI in the coming several years. I think where quantum computers will get really exciting is in that simulation bit that I was describing, where if we have a simulation, and obviously we do believe reality is quantum, especially on the physics level, if we can simulate that better, then AI can also build better technology and engineer better things. And if you watched or have read the three-body problem, right, you can think of sophons, and makes you realize how behind we are in our understanding of reality and of subatomic particles and physics and so on. And I am excited for AI or quantum computers to eventually have an aspect in the simulation or a relevance in the simulation, but not necessarily in the AI algorithms yet.
Thank you all for all these questions spanning that wide range. Sorry to all that I could not take. Sorry for that. But a big applause again to Richard.
Thank you so much. Thank you.
And enjoy an inspiring evening.
Thank you. Thanks all. Thanks for coming.
Sehr gut. Ich muss dich jetzt festhalten, bis wir irgendein Foto gemacht haben.
Okay.